Assalamualaikum and a very good day to our panels. So right now I will try to do a video simulation in MATLAB Simulink. As what we can see here is the thermoelectric generator modeling without MPPT and boost converter. So here is the constant value for TH stand for the hot surface temperature. TC is the cold surface temperature, and this one is the Seebeck coefficient, and this 20 is where I decided to use 20 TEG modules. So without further ado, let's see next is the table. This table is from the simulation that I have recorded the datas, which I use fixed temperature difference of 250 degrees Celsius. For the hot surface temperature, I use 300 degrees Celsius, and the cold surface temperature, I use 50 degrees Celsius. And the load is varies from 1 to until 200 in 11 steps. So let's see whether I can manage to obtain this data with using 17 ohm. So let's go back to the MATLAB Simulink and use variable loads of 17 ohm. Here I change the variable loads to 17 ohm. And we try to run the simulation. Okay, here you can see the current. The current value is 3.922. The voltage value is 66.67, and the power value is 261.5. So for this table, from this table we can see at 17 ohm, the current is same. The currents, the voltage value and the power value are same with the MATLAB Simulink. It is tally. And next we try to do for 75 ohm. Okay, for 75 ohm, we managed to obtain the current of 1.449. The voltage is 108.7 volt, and the power is 157.6 watt. And as you can see here, it is tally with the simulation from the MATLAB Simulink. So next, to obtain this result, which is the thermoelectric generator output curve at the temperature difference of 250 degrees Celsius, I just drag this one and use this chart. And as you can see here, the table is same. The graph is same with this one. So that is how I managed to obtain this graph for further analysis. Okay, for the next one, I will show for a fixed load value and a variable, and the manipulated variable will be the temperature difference. Here I use the hot surface temperature from 60 degrees Celsius until 250 degrees Celsius. So let's try to simulate one of these result. For this one, I will choose 110 degrees Celsius and see whether I manage to obtain this one or not. Okay, for this one, I change to 110. The constant value, and then here change the variable load to 17 ohm, which is the constant which I have fixed for this one. Okay, here as you can see here is the current is 0.9413. The voltage is 16 volt, and the power is 15.06 watt. As you can see here, it is tally with my result. Okay, right now I will show you the TEG modeling, thermoelectric generator modeling with PNO MPPT and a boost converter. So let's see the table first. Okay, here this one is the data that I have recorded for TEG modeling with PNO, MPPT and boost converter. Which is here the temperature difference is fixed to 250 degrees Celsius, and the load is varies as before from 1 to 200 ohm. So let's see for example which I used for 30 ohm, whether I can get this data or not. Okay, here we change the resistance, the load resistor to 30 ohm. Okay. Okay, as you can see here is the time taken for this simulation to able to achieve 100% for the simulation to fully simulation. Okay, as you can see, I have to cut the video because the time took to process the simulations is about 15 to 20 minutes. So I've cut this video until the time it process is about 95%. So let's wait a little bit. Okay, right now the simulation has completely simulate. So here this one is the current is 2.917, the power is 255.2, and the voltage is 87.5 volt. And let's go back to this graph, to this table, and you can see here for the current output, the voltage output and the power output is same and tally with the simulation. Okay, so I repeat the same process to analyze the next one, which is for variable temperature difference with fixed load at 17 ohm. This is for PNO and MPPT, and the next one also the same step, which I only change the PNO MPPT to incremental MPPT, and then use still the same steps for a variable loads with fixed temperature difference, and this one variable temperature difference and fixed load. And next one, I would like to show something which is the at PNO MPPT, there will be some ripples before it achieve to its before it achieve its MPP or maximum power point. So let's take for example, I choose 100 ohm. Let's choose 100 ohm, and temperature difference is 250 degrees Celsius for both PNO, MPPT and incremental. So here I will change it, the variable loads to 100 ohm. This one also 100 ohm, and this one already 300. Okay, this one we change to 300. Okay, just for your information, this upper circuit is for PNO, which is right here. This is the PNO. If I close up this one, okay, you can see here we use PNO MPPT up here, and this one is for incremental MPPT. Okay, so after I have fixed everything, so let's do a simulation. Okay, for this one I have to cut the video also, as long because as you can see here, the simulation took quite a long time to simulate. So once it have achieved 100%, we can try to see the graph. Okay, here I want to show you the simulation, the comparison between incremental and PNO and PPT graph. Okay, the top is for the PNO and PPT, while the bottom is for the incremental. As you can see here, there is a ripple before the MPPT for PNO MPPT achieve the maximum power point, while there is no ripple for the incremental. And the time taken for it achieve to achieve the MPP also is shorter for the incremental compared to the PNO. Okay, here we can zoom in to see it much more clearer. So here is the ripple. I'm sorry because my laptop was not quite good, so the result could not see much clear. It is actually just a little bit ripple, but we can see here is the ripple for the PNO MPPT. Okay, let's try again. Okay, here you can see the ripple. Okay, next one I want to show how the MPPT and boost converter could improve the power efficiency and could maintain the maximum power point. So here, as you can see from the slide, this is the graph that I have obtained. So here I have the voltage for the TEG, the power without MPPT, the power with PNO MPPT, and the power with incremental MPPT. So this one is for the variable loads. So to simulate the graph, I just choose all of this and insert this chart. So here you can see this is the same graph, and for this one is for variable difference, temperature difference. To simulate this graph, we use the same technique. So here is the graph, this is same. So that's all for my demo video simulation. Thank you.